Right, hello, my name is Nick Ierodiaconou. It always presents a bit of a challenge. I'm an architect and designer with an organization called 00 based in London. And through 00, I'm also co-founder of a couple of projects I'd like to talk briefly about today. The first of those projects is called the Wikihouse. Wikihouse is an open source construction system. So the aim is to allow anyone to basically design, download, and print their own house effectively. Use CNC machining, digital fabrication, to produce a kit of parts that you can assemble with minimal formal skill and without any power tools. So it goes together like a big jigsaw puzzle. Looks a little bit like this. So this is one which we've just finished in London as part of London Design Festival. And this was done in collaboration with Arup Engineering and the Building Centre in London. And the whole of this structure was assembled by a team of 8 to 10 volunteers at any given time who worked for about 8 days to complete this structure. And the majority of the frame, which you're seeing here, went up in 2 days. What was interesting about this one for us as a prototype was it was the first time we tried to do this over a 2-story structure, thanks to working with Arup on this, and it was also the first time that we tried to properly seal the building from the elements. So it was fully lined. This was all machined in 2 CNC facilities just north of London, and as I say, it went together with basically volunteers who didn't have any particular formal construction training. And the finished building looked like this. It was clad externally with some cementitious boards, and it included things like windows made from CNC milled frames with glazing laminated in the middle. And as I said, it had an upper level with this sort of CNC stair, which was sort of integrated with a structural frame, which led you to a sort of little roof terrace with views over the co-op. And what for us was interesting, which was this was the first time where we tried to move beyond simply doing structure and looking at some of the other systems of house. So the mission with Wikihouse really has been to explore in an open source hardware sense some of the bigger problems around housing, in particularly also in the developed world, because a lot of people see this and think of the developing world, but actually we were interested in how applicable could this be in different contexts. So looking particularly at the right-hand side of this, thanks to the collaboration with Arup, particularly Francesco Ansamo at Arup, we were able to look at some smart systems for the house. So using an Olimex board and some open source software called OpenHab, which is effectively open source home automation software, Francesco developed this system with a sort of brain for the Wikihouse where you could log in via NFC or QR and control systems through an iPad or an iPhone app. So we had low-volt DC circuitry around the house, which made it was safe, basically, for an end user to wire their own building, plug-and-play lighting, Arduino-controlled sensors for CO2 and humidity and so on. And another interesting development was this by David Poulsen at Arup, which was a mechanical ventilation heat recovery system made from a 3D printed casing and fan, a small DC motor from a toy, and actually a heat exchange unit was made from unfolded tin cans, beer cans basically, which amazingly this seemed to perform pretty much as well as the domestic industry standard product on the market. So all of this incidentally is just been taken down this weekend. So information about this is going to be published in the next few weeks online and on GitHub and so on. But of course, Wikihouse isn't just a project in the UK. There are teams all over the world who are working on their own housing issues around this, and I don't have time to go into great detail, but just a few examples. The team in New Zealand, on your left there in the top corner, are doing anti-seismic structures for Christchurch, and they're also working on legal frameworks to make it safer for people to share and operate in this way around big hardware. And on the right is an example from some students in Colorado who built probably the first inhabited Wikihouse structure. Okay, so that was a quick run-through on Wikihouse. Now I'd like to switch hats and talk about the sister project, in a way, to Wikihouse, which is OpenDesk, which I'm now involved in full-time. It looks at similar issues around digital fabrication and this sort of idea of distributed making, but specifically focuses on this idea that a new supply chain for distributed manufacturing is emerging. So what is it? Well, OpenDesk is a website. It's a website which offers design furniture that can be made locally all around the world. And the whole idea with OpenDesk is that basically, as more designers are becoming familiar with the technology and designing for distributed and for digital, and as more makers are getting access to advanced digital fabrication tools in different parts of the world, that it's possible to connect everyone up in such a way that you can actually sell products that are made locally all around the world. And really what we're interested in is this idea that the maturity of the technology, particularly for things like CNC, which has been around in some ways for the longest, is such that I think we can actually now start to compete at an independent microscale with some of the biggest producers. So we started with one design for a flat pack CNC product, which we developed for a 4-person work desk, and goes together without any hardware, as you've just seen quite easily. And then we went on to design some more products, but more importantly, collaborate with other designers around the world who are thinking about these issues. And in fact, we have a whole part of the OpenDesk site, which is dedicated to people coming and sharing new designs that they found or developed themselves. And then you can basically, express an interest in them, or even with an upcoming development work on now, effectively crowdfund to prototype them and things like that. On the other side of the platform, we have the OpenDesk makers. This is a growing community, currently about 300 around the world, I think 37 different countries, and growing. And it ranges from fab labs to professionals in the B2B supply chain who are basically offering people to make OpenDesk products to order. So because of the digital nature of this, basically you can have most of these designs in one of two ways. You can either download them to make yourself. So for open source examples like the desk, you can basically get, in this case, a Creative Commons attribution license, download the DXF files effectively under that license, and then go off and do what you want with them. But you can also, of course, choose to work with a local professional. And a lot of people choose, even after download, to then go and try and find someone who's offering to make the product. And this is something we're really interested in, because what we really, under the hood, want to explore is this idea that we can leverage this to make a business model for what we call open or social making. So when you buy an OpenDesk product, you're basically committing to pay the maker for machining and for labor and so on, but you're also committing to pay the designer a royalty where that's appropriate of their own choosing, or a voluntary donation towards the use of that design, and that's entirely up to the designer. We don't impose it. And then there's an additional service fee which comes on for OpenDesk, which goes towards ongoing development, but specifically in bigger batch orders, it goes towards helping to actually manage that order, make sure the designer has the files that they need, make sure that delivering the files that they've got, make sure that the maker has the designs they need, and so on, and ultimately that things get delivered. And that gives you a final, transparently communicated price. So the whole thing I find interesting about the digital process is the fact that this enables things to be made post-purchase. And so for the first time, you have this kind of idea of micro-massive production where effectively things are being made in scale around the world, but they're being made post-purchase, which means that they can be more customized and personalized, and also that basically you can catalog the supply chain, which I think is important in terms of the overall transparency that this enables. So you can come along and scan a code or go to URL and post photos and videos and comments of things being made as they're being made, geolocated on the map and so on. And so you get a page like this, we call it the workshop, which is just a feed of DIY and made-for-order products being created. So this model is real. We launched about a year ago. We got some funding earlier this year, largely down to a crowd equity campaign we ran, and here's some quick headlines. The most important two, I think, are the bottom two, which is we focused on trying to be involved in orders in the UK and specifically New York initially, whilst there's a whole load of making that we don't track, if you like, that we don't follow going on in the open, in the wild, elsewhere. But just in the UK and New York, we've generated £160,000 of revenue for these local independent makers, and all of that without any money spent on marketing by any party, including ourselves. And we're lucky enough to be working with some great people who are supporting this, mainly workspace customers, because we've focused on workspace initially, and all of these orders are being made by local production points like this. This is a workshop in New York, Associated Fabrication, that we work with, here working on an order for DigitalOcean in New York. And when I talk about local, the thing I think is potentially quite empowering about this in terms of our view of the overall global supply chain is just how local some of these pretty professional makers or pro-am hobbyists who are entering the space and delivering really great results are. So this is an example from Maker Faire in New York, where we sent a design to a new maker we'd never worked with, and they produced a piece where the supply chain delivery radius was 15-minute drive from point of production to point of use. So what have we learned? Well, we've learned that there is an increasing amount of choice out there in terms of designs or design variants from more product designers who are starting to think about these issues, and I think that's only going to increase. We've learned that the reach and exactly the demand for these sorts of products is growing. Makers, designers, but also interestingly lots of customers who are starting to care about how stuff's made and who's involved and where it comes from. And interestingly, that already with very little management, in middle management at all, in fact, there is an affordability to these products which sits somewhere between mass-produced products at one end of the spectrum and sort of high design, high street products at the other. And perhaps most competitively is actually the turnaround time. So you can place an order for a product from a local maker, and of course, because it's in many cases down the road, really, you're getting things in 1 or 2 weeks, even with some customization, relative to, say, 6, 7, 8, 12, sometimes weeks from a contract fit-out company. And of course, there's a local economic multiplier, and money is returning to the producers. But we've also encountered a whole load of challenges on this, so not least around things like file formats and interoperability, interfacing with CAM software and things where industry standards just aren't there at this end of the market, but also obviously issues around quality assurance and liability and warranty, which we're just starting to try and navigate. And one of the most interesting ones in the context of today is really this question, which is, in a changing landscape, thinking not only about the whole spectrum of open source, copy left, far left, and so on, but also right down to that thorny issue of non-commercial, is what actually designers who are thinking in the product space and in the big hardware space are comfortable with. And what we found is actually there's a huge amount of uncertainty around what the real implications of choosing a license are. And rather than be dictatorial about this, we've explicitly decided to be agnostic and try and learn with designers about the implications of different things they choose along the way. And I think this is only going to become more of an issue because we're starting to explore things like this. So this is a company called Matter Machine based in New Zealand, and they develop in-browser parametric software, and we're partnering with them to try and explore how much control we can give from the designer to the end user or to other designers in interfacing with parameterized designs on their products. And of course, this raises huge and interesting issues around what are the liability issues. And I don't just mean legal liability in terms of who's going to sue me, I mean actual moral responsibility, moral liability and moral responsibility issues around giving control for big objects like furniture and particularly things like housing to end users. So whilst I think we're really interested in technologies that lower the threshold for access to increasing interesting and more rich ways of producing, we also have to accept as creators of these sorts of technologies that we are presenting the world with new capabilities that will go beyond our control at some point, in which we need to accept a high degree of moral responsibility around. Thank you.